It starts recording now. So as I said, that this conceptual design talk about the main concepts, which is the main entities we have it here, and their characteristics, and how they are related to each other. So I don't have to think now about the database management systems that I have to use it. I don't have to think about the data model that I'm going to use it. I should focus more about the concepts or entities that I have it here. The logical design, now I have to think about the data model, not the database management system. So the input for this logic database design will be the conceptual design, which is in our case, the entity relational diagram, like here. So we have it, this is the conceptual design here, which is the ER diagram that we are going to discuss today. It will be an input for the logical database design. Here, I have to choose a special data model, like the relational, like here, which is set of tables. So the input for this phase will be the output of the conceptual design, which is an entity relation diagram. I should have already agreed in a data model like the relational one. However, I shouldn't take a decision for the database management system at this level. At the physical database design, here, I should consider a special database management system based on the logical design that I have it. So since I will have now the logical design based on the ER diagram that I will construct it, now I can go to the SQL code because I should write a special code that it is somehow compatible with this database management system to construct physically my tables or my database structure. So today, as I said, we will be here. This is, as Papa said, get ready, we'll discuss this today. So let's start. ER entity relation model. Like always, I always like that we know about people who has already helped us to propose this to us, that they have really impact in our domain. This person, his name is Peter Chen. In the 1970s, he started his work and he proposed his final version, 1976, about what he named it at that time, entity relation model, or a unified view of data. You see this word that he used it because at that time, we start to have speciality, which means that we have a people that design the database, not the same people that are going later to implement this database and work with it. So the database designers should have a standard way to sketch different level of design. So this person was the first person who has to propose the unified view, which is the unified sketch of a database design in this case. So it's based on entity. So what is an entity? An entity is anything about which we store data. Like I said, I'm building an ER database software for a university. So anything need to store data for, anything has a characteristics and attributes, properties, for us can be an entity. Whenever there is a description for this concept, which is a thing in a real world was independent existent, which means that it has its own description, it has its own parameters, and can be distinctly identified. For example, in a university database management system, a student has an ID, a date of birth, an address. So it has its own description. It is a total independent entity within this system. And there is a parameter that I need to save values for them. It can be an entity. If I am talking about I don't know, an asset like a chair or whatever it is. I'm talking about maybe about exams as an exam. If I'm not going to save them in the system and they don't have a parameters, so they are not be an entity for my system. Here it is very important to define the entities, to define the concepts you have here. It is extremely important to do this. So example of entities is if we like employee, doctor, these are all entities. Like if we are talking about object building, if I'm doing a real estate management system, it can be an entity. If I'm doing a system for car trading or car renting, a car itself can be can be here in this case an entity. If, for example, even though I have a system with different transactions, sometimes each let's say based on a transaction, I can have a different properties for this. Like I need to have today's sales and date of all sales about with whom is being done by this sales. So these can be also entity. All these entities. Again, this depends about the requirement because the input, as I said here, the input for this conceptual design is the requirements. Based on the requirement, we get a conceptual design. And based on this conceptual design, we'll go to the logical design. So based on the requirement, we will have our conceptual design. Let's return here. So now if we are going to start sketching our E-entity relation diagram that talk about the entities we have it here, plus their properties, plus there's relationship, plus there is inheritance that we will discuss it later. How I can do this based on which standard? Because I should draw a sketch that any person is going to read it or to double check it can understand the content of the sketch. How I can do this? So there are more than one standard for this. And I am telling you about the standard because later when you go double check online, you see that we have different standards. So in this course, we will use the Shen standard. Why I choose for you Shen? Because it is the easier one. It is more simple comparing to the other. And you in this level, it will be perfect to be familiar. And it is, by the way, it is 70% or 80% about the ER diagram style that's being used still. It is a Chen one. There are more specific based and different standard later, like this one is being already used also, and this one. However, for us, we will use a Shen standard. So how Shen will work in here? Shen says that an entity, as we said, is anything that we need to collect values or save values for this and have a parameters. And this entity will have, here's this word, different instances. Like this is the name of the entity is car. The attribute is year, model, make. So in ER diagram, I will resemble the entity at set, which is set of all instances from this entity. Like here it is, here this is an entity 1, entity 2, entity 3. Maybe I didn't name it entity, let's say instance 1, instance 2, instance 3 from this entity. All these instances, I will name it them as entity set. Some people name it this entity type. I will choose for you the entity set. It's more accurate to use it like this. So again, if you go now to some references, they use the word entity type. I will use, some of them, they use the word entity set. So entity set in our definition will be all instances for a special entity. Like here, so this is instances 1, instances 2. So if you are doing a system again to university management systems, I build a student entity, I define the attributes, and then each one of you can be the values for each one of you can be an instance for this. So an instance set in ER diagram, we will resemble it, the name of it with a rectangle. You can do it as a triangle. It should be based on this, it should be a rectangle. And for each attribute or parameter, we should have an oval here where we write the name of the parameter or the attribute. And there should be a line from the rectangle of the entity to these parameters. So this is how we resemble entity set with its attributes in an ER diagram. So what different attributes we can deal with it? The first one, it is the simple one. Like, so you have an entity, you have an attribute. So the simple one, like job, employee, name, salary. And then we have different types of attributes that we are going to discuss. So again, an entity set, we will have an entity name. In a rectangle, we have different attributes. And now we will discuss later the entity set, the different kind of attributes that we are going to deal with them. Brain, have a question here. Ready for the questions? We have a lot of questions today, by the way. And I always take notes for people who is here that are participating. And we have this is as a recorded, and sometimes I have to return back to the recorded video. So Brain is asking you, if you were collecting and storing information about your music collection, you want to build a software for a music collection software. An album can be considered an relation entity instance attribute. So based in here, an entity so far, it has an entity, it has an attribute. Like here, it has an entity here. This is the entity name, this is an attribute, and this is the entity set. The question of Brain is, if you are going to collect and storing information about your music collection, so an album can be considered as a relation entity instance attribute. So I think so. I have here Josh, Kura, Callum, Simran, Harmandeep. So Josh, I think so based here, what I can see here, it is the first person that already has rises on. Go ahead, Josh.
Couldn't it be considered both an entity or an attribute depending on what you're actually sorting? So say you're looking at the songs specifically, then the album would be an attribute of those songs. So it's like, oh, what album is it from? But if we're just looking at albums themselves, it could just be an entity that contains those songs as kind of like attributes.
Okay, I will hear what the other will say, and then I will discuss it with you. Callum, I'm saying your name correctly. Callum Brisden.
Yeah, that's right. Would it be an entity because albums would have like a track list, like the artist when they got released? So
it is an entity only in this case.
Yeah, that's what I would think.
Yeah, thank you so much. Simran.
Hi, I think it's an attribute of the music.
It is an attribute. So we have an answer say it is only entity, an answer say an entity, an attribute, an answer say only an attribute. Okay, Harmandeep, Thank you, Samran. Harmandeep,
I think it's entity.
entity or attribute? You said attribute. Harmandeep now talking, yeah? Harmandeep, sorry. Yeah, go ahead, Harmandeep, entity.
Yeah.
So Harmandeep say entity. Please, who finished, just lower your hand in order not to be confused if you still have a question or you want to participate. So Harmandeep and Samran, I ask you kindly to lower your hand. Ikamjut.
I think it should be an entity.
Entity. And I have the last one today is for this exercise is Kura. Thank you so much, Ikamjut. What do you think, Kura?
For me, it is an entity.
It is an entity. Okay,
Yeah.
so yeah, our colleague, I think so. Just Callum has a nice reason for choosing an entity. He said that we need some values for this. We need, I don't know if I missed somebody in the chat. So entity. Yes, most of the people in the chat say entity. Cannot it be an entity and an instance depending how you are storing the music? It is not an instance because an instance should be a specific album. I think it is an entity. All of them, Nissan, it will not be all of them. So for us, let's first redefine what is an entity. An entity is anything that has its own unique existence and it has its own descriptions and attributes. So whenever you feel that this thing, I need to store some values for this, then it should not be anymore an attribute. It should be an entity. And it is not an instance. An instance is an accurate example of an entity. So in this case, it is not a relation so far because in ER diagram, there is nothing we name it relation. It is an entity. Later, when we will go to the logical design, we will name the table as a relation. But we have something, we name it here relationship. So it is not a relation. There is somehow this terminology. So it is not a relation. So it can be either entity or instance or attribute. As I said, if it has its own values that need to be stored or saved, then it has attributes. And if it has an attribute, then it is now an entity. An instance is an example of an entity. So the album, I need to know about, for example, I should have an album name. I should have an album creation date. I should have an album list of songs. So there are three main attributes. We will have more than one attributes. Since there is some values that I should save it for this concept. In this case, it should be an entity. It is not anymore. It is not anymore an attribute because it has its own independent existence using its own attributes in this case. I can say, for example, I have already created later, I saved a data for a special album, like just album 1. Date of creation is today. It has 12 songs. So now it is an instance for this. Simran, do you want to ask something? Because I saw that you have already raised your hand.
Yes, I wanted to ask, like, if I have multiple albums, so won't they be an attribute of my music information?
Yeah, multiple albums, you mean that different examples? It is an instance. This is the entity set.
Okay.
Yeah, returning here to this example. So I have an entity here, I name it car. I define the entity attributes. Don't mix now. I know this is the beginning of database design. We are building the structure. So we are talking about what is the main concepts or entity we will have it here and their value and their attributes. And
Okay.
later we will save, after we construct our tables or relations, we will save for this entity different entity instances, which will be album 1, album 2, album 3, like here. This is an example, this is another example. Each one of them, and this is very important, each one of them should have 3 values, as I have already mentioned or proposed in my ER diagram. So if my ER diagram, I have a year, a model, and make, and then I should have it here. Nissan is, and Skyline is a model. Here I have a year, and here I have the mark. I use Nissan. So I have to have 3 main values for each instance in this case.
Okay, understood. Thank you.
Sure. So this is an entity in this case. So, and by the way, if it is an entity, it can be an attribute. We will see something, we name it composite attribute. We will discuss it later. But if I define it, it cannot be defined an entity and attribute at the same time. An entity is an entity and an attribute is an attribute. We will never have something we name it an entity and attribute at the same time. This is for you, Josh. Which would not likely be an attribute. Now we have another question. Which not likely to be an attribute of entity called student? So, age, student identification number, classroom number, home phone. So we have an entity, we name it a student, and we are defining the attributes for this. So the question of Brainy, which there is one of them, it is not an attribute, not an attribute. Which one? I will start with Ayman Arif because she's the first one she raises hand. Go ahead, Ayman.
It's going to be the classroom number because it does not describe the student.
Okay, perfect. Thank you. What about Sarsak?
Yeah, same. It should be classroom number.
So I have 2 persons saying this. Simran.
Yeah, it's the classroom number, I guess.
Josh.
Classroom number.
Ivan.
I think it's classroom number for those reasons. So.
Can you speak somehow loudly?
Sorry, yeah, the lawn. Someone is cutting their lawnmower right when I'm trying to answer my question. I think it's classroom number because, like the others said, it doesn't describe the student, and also because, like there will be multiple classes for the student.
I see. Thank you. Okay, I have still Karamveer, and go ahead, Karamveer.
Yeah, I think it's a classroom number. It's not related to student.
Thank you. Karamveer.
Yeah, it's classroom number, not directly connected to a single student.
Thank you so much. I'm double checking also the chat. I see that most of the people saying it is a classroom number. I don't have. That's good. Yeah, I totally agree with you. And as Ivan has already said, that Ken, do you want to add something? Because I see now you are raising your hand, Ken.
Sir, would it be always classroom number? Imagine if we had one I don't know, online course you're taking from an online website,
okay.
Or for example, or you're taking only one course per semester. Could it be possible that in that specific scenario, classroom number is an attribute of this entity student?
Okay, thank you so much, Ken, for your question. No, it cannot be, because if in the requirement I have to save data about the online courses, in this case I have to create an entity, I name it online course, I will add different attributes for this entity, like the class roll number or whatever it is. Even though it is online, there is no class roll number. So if there is, in this case, I will create an entity, I name it a class, and then I add a class roll number and a class online, offline, or online, or in person. So because this entity is not describing, sorry, this attribute is not describing the student, as Eamon has already said. So in this case, it should not be part of the entity in this case. Paramveer, do you still have a question? Thank you so much, Ken.
Thank you.
Paramveer. Okay, Josh, do you want to add something here?
Yeah, I was just going to add on to what was just said. What if it was, we were talking about elementary school students who don't change classrooms, they stay in one classroom, so would that be part of that entity then? Say yearly or something, you would update the database or something, but
Yeah,
it could be kind of there.
This is what we name it. It is a bad design if you do this, not to have a homogeneous and attributes within the same entity. And this later we will discuss it when we talk about normalization. Mean that if you will add some attribute to an entity, and the value of this attribute will be a few values, and most of the time it will be null, then we name it, this is data redundancy. In this case, you are saving null value for many instances, and you are consuming your space that your database management system offers for you. And this is a bad design. This is why from the first time you start building your database structure, you should be aware that to include the attributes that they believe they describe all instances in order not to have so much null values. Do you agree with this, Josh? Josh, are you still here?
Yes,
Josh?
sorry, I said.
Yeah.
Hello?
We were not hearing you. Now we can hear you. Go ahead.
Okay, yeah, no, I had said yes. I guess my mic didn't unmute fast enough. All right,
Yeah.
thank you.
Sure. Kura, go ahead. Do you have a question here?
I just want to add, we can create two identities like student
entity, you
and
mean?
classroom, yeah,
You-
and we
you-
create relation to
Yeah.
that.
Yeah, you mean two entity, not
Yeah.
two entity. Yeah.
Yeah,
You are
two
correct.
entities, then connect or relate that two entities.
This is what we'll do today. Yeah, very. Yeah. Well, thank you so much for sharing this, because we can build a relationship with these entities. So we can build another entity. This is what we are going to, in the next slide, to discuss about the relationship. We can build another we can build another entity, and then we will make a relationship between two entities in this case. Yeah, this is what we are going to do it in this case. Let me double check the chat to be sure that this. Nassan here say that could also be a home phone number if they share the phone with another family member. No, because an attribute doesn't have to be unique. Only an attribute can be unique if it is a key. This is what we will see later. So if an attribute is a primary key or a key, it shouldn't be unique. If it is not a primary key, then if it is a primary key, it should be unique. If it is non-key or non-primary key, we can have a duplication for sure. For example, suppose it is a student in a kindergarten or in an elementary school, and you will have more than one kid in the same school, so they all will have the same home phone number because they are siblings. They are the same family members. So we will discuss later about what you mean by key attributes. These attributes cannot be duplicated. It should be unique in this case. So class roll number, as you have already said. So let's go now about what different types we will have. So we will have the simple type. Like here, this is a simple attribute. A simple attribute means that it will have a special value for a special instance. I am an employee at UFV, so my job is an assistant professor. This is my job. I will have a one value for this. However, sometimes we will have an attribute. It is not an instance. It is an attribute for this entity. However, this attribute can be break down to different sub-attributes, like the address. So in the address, we will have a street, a number, an apartment. So when you design your database, to be sure that you have three main values for this attribute, then you will create different attributes related to this attribute. Again, it is not an entity, it is still an attribute. However, we break down the attribute to different sub-attribute, even though it is not being used, the word sub-attribute, but we can use it here just to clarify it. In this case, we name it a composite attribute. So a composite attribute, it is an attribute that can be divided into small subparts, and for each subpart, it has its own value for this instance. Here we will have the address as a composite attribute and the street address as a composite attribute. Both of them, they are composite attribute here in this case. However, the name, it is a simple attribute. The job, it is a simple attribute. So a composite, this is another example of composite attribute. Sometimes if I want to break down the name for three different subparts, like the first name, middle name, last name. So in this case, it can be a composite attribute. Again, who will tell me if I should do it as a composite? Yes, no. It is based on the requirements that I should have collected from the stakeholder. Stakeholder is the owner of the system, the user of the system, the people that later they're going to interact with the system. So I have already collected the requirement, because sometimes when we will have something missed in the design, it will not because as a designer have missed something, maybe because the requirement, they are not complete or not accurate. I think so in your program later, you will have different courses that talk about how you collect requirements. But it is, by the way, even though it is a pre-step before database design, it is a very essential step and should be systematic. Because what I'm building here based on the requirement. So if the user tell me that I need the name to have three main values always, first name, last name, and middle name. So when I will construct my ER diagram, I should mention that this attribute is it is a composite. I will ask you before I forgot, and later after the break, I will share you the file. But so far, I will ask you that each one of you write present in the chat. Write the word present, each one of you, just for attendance collection. I think so. We can continue. So we have something we name it multi-value attributes. Multi-value attribute is not like the composite attribute. The composite attribute means that there are different subparts or sub-attributes related to it. The composite attribute, the multi-value attribute, we will have for the same instance more than one value for the degree. For example, for more than one value for this. For example, you as a student, later after you finish, maybe you will have 2 bachelor degree. or you have a bachelor and you have a master, and you start your PhD now. For the same, me as Ismail, for example, I have 3 degrees. I have if I'm now a student in another institute, so and they are going to collect information about me, and they ask me about my degrees. I said I have a bachelor, I have a master, I have a PhD. So Ismail has 3 values for the degree attribute. I'm not talking about like the address, street name, and apartment, where you will have a different subgroups or subpart. No, I have only one attribute. However, for a special instance, I may, not all instances, I may have more than one value for this attribute for this instance. Like the case, if I now registered in an educational institute as a student, and they are collecting information about me, one of the information about your degree. So in this case, for Ismail, they should have 3 values: bachelor, master, PhD. For example, for a car, for the same car model and mark and year, we will have different colors. Like here, when we talk about returning back here, yeah, Toyota Camry 2005. I have a Toyota Camry 2005 red. I have Toyota Camry 2005 blue. I have Toyota Camry 2005 yellow. So for the same instance, I will have for this multi-value attribute more than one value for the same instance. And when we will, in the ER diagram, we have to do this, we should use a double line for this attribute. Double line. Double line means that it is a multi-value attribute. Again, we are using the Chen standard in our ER diagram. So any person later, after we construct our ER diagram, can go ahead and read it. We said it's based on Chen standard. He can or she can understand using different terminologies or standards here. If I use a double line for attribute, mean that it is a composite attribute in this case. So derived attributes. Derived attributes. Sometimes the stakeholders tell you that you as a person later, I need to collect the age to save it in the system. However, I shouldn't pass the value for the age when I collect the data, because after you build your software, your database system, you are going to create different interfaces. And these interfaces will go ahead and insert the values in the database using these interfaces. So for the student, I will insert the name, the address, the birth date. However, I will not pass the age. I will ask later the system to calculate the age based on the birth date. Because if I will enter the birth date for the student, I can, using one line of code, I can estimate the age. However, I need the age and attribute, because maybe later when I will make a report, I will not calculate each time the age for the student. I will double check what is the value in this attribute and to build my report. So I want to save the age for this student. However, this value is not going to be entered later. It should be derived, estimated by the system. So in this case, we will put it as a dotted line, as you see here, or a dashed line like this. So this is, we name it derived attribute. So age is called a derived because birth of date is a stored attribute, which means the attribute that we will store the value, and the stored attribute is the attribute that based on the stored attribute, we will later we will estimate the value for this. We have a question from Brainy so far. Ready? Okay, the question says, select the attributes which made up of more than one single attribute. Select the attributes which made up of more than one, which are made up of more than one single attribute. Are these attributes multi-value attribute, derived attribute, single value attribute, or composite attribute? So I have so far 2 answers. Both of them say D, composite attribute. No, don't. Yeah, just if you want to talk, I'm happy. I want you to share. Yeah, just raise your hand and do it. I'm telling you what I can see in the chat, but I will. So Simran, go ahead.
It's a composite attribute. Composite.
Thank you.
Yeah.
Harmandeep.
Composite for sure.
Ayman.
Yeah, it's gonna be composite.
Kamjut. Yeah.
Yep, it's D.
D, so it is composite. So I think so all of us agreed it is a composite. Ayman, I'll ask you kindly why it is a composite attribute. Why? Ayman.
Because it can be broken down into more relationships.
Not relationship, more attributes.
Yeah, sorry, more than one.
Yeah, don't worry. I know it's something new for you, but just I have to be sure that you are using the correct terminology. So it will be composite down to different attributes in this case. So yes, so the attribute which made up of more than one single attribute, it is a composite attribute. It is not more than one single value. In this case, it will be multi-value attribute. Do we have something in the chat? No, there is no question in the chat so far. Okay. So now we should discuss about key constraints. We have more people joining us. So key constraint, it's talk about what we have already so far discussed. Could you say a derived attribute is made up of more Nassan? Could you say a derived attribute is made more of more than one attribute? It's relies on other attributes to exist. The second part of your statement, I agree with it. The first part, I don't agree with it, because the multi-value attribute. Sorry, so I'm talking about the derived attribute. The derived attribute mean that. Wait. Could you say is made of more than one attribute? It is not made of more than attribute. No, it is made from one attribute. However, the value for this attribute, we are going to derive it or estimate it or collected using another attribute. So this attribute need another attribute to get the value for this. We will not insert later the value manually for this attribute, Nissan. Yeah, Josh, you are correct. It's more about calculation based. So as we said, it is more about calculation based. So yes, so they are not as 2 attributes like the composite one. Each one is a standing alone attribute. However, the value of the first is calculated or estimated using the value of the second. So before I will go to the relationship, maybe after finish this, I will go to the relationship. I will give you a break, and we will go later after the break about relationship. So let's talk about key attributes. So far, we said the type of attribute. We have a composite attribute. We have a derived attribute. We have a simple attribute. We have a multi-value attribute. What about the key? Because I think so. Nassan also has already, maybe or somebody else, I forgot, has talked about what is if it is unique or something like this. I forgot how it was, but so the key attribute in each entity, we should have a key. A key can be an attribute or more. Again, it can be an attribute or more. A key is an attribute or a set of attributes which is unique. And it is a must always to have a key. It is a must always to have a key. In some special cases, we don't have a key. In this case, the entity, we name it a weak entity. This is what we will discuss it later. But we should always, after we finish constructing our entity set, by giving a name, the attribute, giving the type of the attribute, the next step should be about choosing a key. Why we need this key? Because later, if you want to search in the record or the values in this entity set, you should have a key where you can go to a specific record or a specific instance or a specific value. And this is a huge set of values, which is the key. Like here, employee, the social security number alone can be a key because it is unique, no duplication. We will never have two employees having two social security number or the same social security number. It is unique in Canada and in different countries. So each person has his or her own social security number. Another example here about course. Sometimes I have to put the course code, like here, for example, and the department, COM 230. So 230 is the code, comp is from the department. If I said 230 alone, I will have two different many courses 230. But if I said comp 230, then now I have uniqueness. So in this case, department and code with each other can be a key, which means a department alone, I will have different comp, but and we'll have different 230, but I will never have in the same record, which means for the same instance, for two different instances, I will have department and code the same in this case. Go ahead, Josh.
Yeah, just a quick one. Would the code be an attribute of the department at all, or would that just be still separate?
No, it is still separate because it is not part of the department. It is not a composite one. It is separate attribute, and it is a standing alone attribute, and it has its own value that it is not related to the department. However, the value of the code and the value of the department cannot be duplicated for different instances. So if I have a course 1, course 2, course 1 will have a department a code, and course 2 will have a department a code that will never be the same. So let's take an example. So let's take the instances here. So I can have a course comp, sorry. See, comp, this is course 1. Course 2, comp, here 230. Here I have 240. I have course 3, CIS, or suppose business. Business, BUS, 230. So 230 for the value of the code can be duplicated, and the comp can be duplicated, but both of them cannot be duplicated for the two values. I will never have another comp 230 here, for example. So both of them in this case can make a key, not one of them, not like here, social security number. Only this attribute can be a key in this case. So a key can be an attribute or set of attributes where they are going to be unique in our entity set in this case. Is it okay, Josh? In this case, wouldn't the key attribute need to be something like CRN, since we can, yes, it can be a CRN. Yes, This is why we have a CRN, by the way, in our university, and which means that this is a unique identifier. Yes. Again, this depends on the stakeholder. If the stakeholder tell you, I will create a unique identifier, as they do for the student. So in this case, I can say, in this case, I can say, okay, I no need to create more than one key, more than one attribute. I can choose one attribute, which is the unique identifier. So yes, the CRN that we have it because the stakeholder of the UFV system said I can create a unique identifier for all courses where there is the day, the semester, I think so, and the year and the code. So it had a unique identifier in this case. But in case we don't have this value, we still can create a key using more than one attribute in this case. Any questions so far for this? It is very important always to define keys and attribute in an entity. Okay, guys, I will give you a 12 minute. So it is 9:38. We will return back 9:50. I will keep everything recording and everything. Go ahead, refresh, because I need you to be full concentrating now for the relationship part that we are going to discuss. So we will be back 9:50. See you soon. Okay, I will just turn off my camera, and I will turn off my mic, and I will see you later. Take care. Hi guys. Are you back? Hi, Zach. I will share with you the link. This link. This can be, I will share in each lecture a link, and then this file will not stay for a long time here. People has already written present today. I will ask you just to go to this file now and put P at your name, P. Which means that if, so go to the file and write P. And later I will double check this file with the people that have already written present in the chat. So kindly, each one of you can access this file using his or her UFV access and write P. Not here, not here. Go to the file, Wilson. Go to the file. I shared with you a file. And write in the file there, please. I shared file in the chat.
It's in read-only mode.
It's read-only mode?
Yeah.
Even though when no. Let me double check it again. Manage access. For people in the phrase of even though I said here, share, can edit. People in the phrase of value can edit. Yeah, I'm double checking it to see how I can do it. Maybe I have to go, maybe when I share it here, let me double check it here. Copy, share. Oh, okay. I have to change it here. Because I share it in the cloud. I think so, and I have to make the permission here. You should be able to do it now. Try again, please. Can you try from your side to be sure that I think so you should able now to do it?
I still can't do it.
It's strange. I said editing, make any change. Oh, if it will take time, forget. I open in, I share it. Strange. I give you the share here. Can edit. Share links and try again this one now. Try again the second file I send it. Cannot do it. Okay, try this second one. If it doesn't work, forget about it. Maybe I will do something on Google Sheet later. And I put your name, so still not so okay, forget about it. I will collect manually now and by myself all your presents. And then next time I will share with you maybe something, I will collect all your name and give you one by one permission. Forget about it today. So just be sure that all of you have already mentioned present at the beginning of this lecture. So it's okay. Don't worry about it. So let's now start with the relationship. So what we have already discussed so far, we talked about what is an entity, what is an entity set, and how we can resemble this in our diagram, what different attribute we have it here. And we have already talked about different types of attributes. And before we go to the break, we talked about the key. What is a key? And we said a key can be one attribute or more, and they should be unique and no duplication, which means that two different entity sets, so two different entity instances, they can't have the same value for the key. Let's do about relationship. So relationship, we believe, since we are going later to go to a relational model, we believe that these entities, they are talking about a special software from a special ecosystem. So they should have a relationship between each of them. And it is a rule that when you build your entity relation diagram, we shouldn't have islands, which means that you shouldn't have an entity set standing alone without any relationship with the other. At least it should have one relationship with other entity set. And an entity set can have one relationship or more. It depends about the requirements you have for the system. So an entity here, we can see it like we have an employee. We have an employee. And we have a department. The department, the employee here, it has its own attribute. This is the key. And the department has its own attribute, and this is the key. And here we can see the location is here is a multi-value one. We believe that if this is the instances of employee 1, 2, 3, 4, and this is the instance of department, we can see that one employee should work in a special department. Works for. This is a relationship. Works for. Another employee work in a department. So one employee should be an employee in one department only, maximum. And a department can have more than one employee. So the role of this entity set in this relationship, it is a worker. And the role of this entity set is employer. Sometimes it's good to know the role in order to understand more the relationship. How we can resemble the relationship in our diagram using diamond. And we write here the works for the name of the relationship. It should be a diamond. You can do it as a square or a triangle. It should be a diamond. And it should have a line from the first entity set to the second entity set. And more to become later when we talk about restriction. So far what you should know that we should have a diamond whenever there is a relationship based on the roles of their interaction. This is when we talk about the degree of a relationship, we name this as a binary relationship. Why it is binary? Because the number of participants in this relationship is 2, employee and department. So in this case, we name it as a binary relationship. Because we believe this binary relationship because we have just 2 entity set participating in. What about this? So a bookshop sells book. Members like books, and members frequent to this bookshop. So this is a frequent, so they go frequently there. Each one of this relationship is binary because we have 2 entity set participating in this relationship. And we can have one entity set that will be involved in two relationships like members. And also the same bookshop. So all of them, they are binary relationship. Here, we name it ternary. Why we name it ternary? Because this relationship define a relationship between three entity set. A member prefer this book from this bookshop. So in this case, we name it ternary. And we maybe will have a relationship for 4 entity set, 5, 6, so it will be degree of n based on number of relationship involved. So we name it here binary ternary, but we can have 4th degree, 5th degree, 6th degree. It depends about how many entity set is involved in this relationship. Now, we are going to talk something we name it constraints. And especially in binary relationship, and we see it also in non-binary relationship. But let's take the binary because it's more simpler to discuss it. Constraint, there are 2 types of constraints. The word is constraints is about restriction. Why we need to have a restriction of constraints. By the way, I just have a question. You can see my camera? Because I'm opening from 2 places. I want to be sure that you can see my camera.
Yes.
So that's good.
Yes.
Yeah.
Thank you. So the constraints on binary relationship are 2 types. Why we need to have a constraint? Why we need to have a restrictions? Because sometimes based on the collection of the requirement, there are some restrictions how these entity set will interact with each other. And this restriction, we should resemble it and consider it in our ER diagram. There are 2 types of constraints or restrictions. Something we name it Cardinalary Ratio, and something about participation. Both of them, we name it structural constraints. Why it is a structural constraint? Because it is a constraint on the structure of the database, not on the data of the database. Later, we will learn this course, how we can make a constraint about the data that we are going later to insert in this database. For example, you are collecting date of birth. The months should be a number between 1 and 12. This is not a structural constraint. We can name it more, it is a data constraint, a constraint in the data that you are going later to save it. And you consider it when we are going to do it, and maybe later in when you build your database later in another step. But here we are talking more about the constraint, about the structure, about the constraint, about the interaction of the entity set. So let's start with what we name it Cardinalary Ratio. So what it's about? It's more about when these 2 relationship, two entity set will interact with each other. What is the maximum, again, what is the maximum number of instances from one side that will interact from the other side? For example, employee and department. One employee maximum can be in one department. And one department can have more than one employee. So in this case, we name it as employee works for one department and a department works for an employee. Or it has an employee. So from the employee side, the relationship is 1 year department, works for one department only. From department side, if I will read it, again, by the way, how you write it, the relationship, it is very important to understand the flow of the relationship. So works for. Employee maximum can work for one department. And a department, in this case, can have an employee in this case. Controls. A department can have any project, but each project should be controlled by one department. So 1N. This is, we name it a one relationship. The ratio, the cardinality ratio for this relationship is 1 to N. There is a side where one instance, an instance can be related to maximum one instance from other side, like the employee maximum one instance. And here, the instance from a department can be related to N instance from here. 1 to N. One-to-one relationship. If we have another relationship with department and employee, manages. So we have few of employees can be manager for a department. Still, they are employee. In this case, we will say an instance from here can be a manager for maximum one department. And a department can be managed by maximum one employee. Not it has many employees like this relationship. So we talk about management, manager. So in this case, it is a one-to-one relationship. Many to many, M to N, many to many relationship. Like here, projects and employee. And one employee can work in a project, or one employee, another employee can work in two different projects, like here. Employee 2 work in project 1 and work in project 4. So the maximum number that an employee can work in a project will be N, whatever it is N, which is many. And this project can contain M employee, like P. It contains employee 1 and 2 working in it. So it is many to many relationship, reassembled by M to N. So M to N, it's easy. 1 to 1, it's all. But here, 1 to M, 1 to many, you should be aware about where you will write the 1 and where you write the N. You should be aware about this. You can use M or N, it's okay, but it's better to use N in this case. It's the most standard to use it. Participation constraints talk more about we have the Cardinalary ratio, that's good. However, sometimes this participation, either it will be many or one, it will be fully or partially. Fully or partially. So fully or a total participation or a partial, which means that all instances will be involved in this relationship from this side. So it is a fully participation from this side, total participation. If some of them will participate, some of not, in this case, we name it a partial participation, like here, for example, managers. Not all employees will be participant in this. So it is a partial participation from here. If it is like here, employee, all should be employee works for a special department. So it is a fully participant from here. How we can resemble this in your diagram by using double lines. So if there is no double line, it is a partial. Full line, double line, it is a fully participant. Like here, not all employee will be involved in this. So it is one line. All employee works for a department, double line. There is no department without employee. All department has employee, double line. All department should have a manager, double line. There is no project without employee, double line. All employees should working in a project, double line. If the requirement said not all employees work in a project, then in this case, it shouldn't be double line, it should be one line. If the requirement said that all employees should work in a project, it will be double line. So who will talk about a full participation or partial based on the requirement that you have? And And in this case, what we can do that what we can do in this case that all of you, if you now go ahead and read this ER diagram, you can understand more about what's happening in this ecosystem. You can understand that we have 3 entities here, project, department, and employee. I can understand the proprietors, the key. The project has a name and number as a key. The employee has a social security number. I can understand also that all employees should work to a maximum 1 department. This is a constraint from the requirement. I can understand that not all employees are managers. Just I can see this from the ER diagram based on this standard. This is the same when you are building or constructing a home. So the architecture or the engineer should draw first different sketches for different level of buildings. And based on this sketch, you can understand more how this building is going to be. Having this ER diagram now, I can now go to another level, to the logical design, for example, to talk more about how I can start choosing a special data model. Because at this level, we are not talking about any data model at this level. We are not talking about any data model. We're just talking more about the concepts, the entity set, how they are being described, their proprietors, the relationship involved, the constraints of the relationships, the key for these relationships, for this entity set. So we have some special relationship, we name it recursive relationship, which is a relationship sometimes we need to describe it here when we talk about relationship, about people in the same, or about instances in the same entity set, like the entity set employee. We have here an employee and we have a supervision as a relationship, because some of the employee will be supervisor for other employee. So it is a relationship between employees itself or themselves, or between the employee entity set instances. It is not a relationship with another entity set, like the manage and department, because it's going to manage a special department. Here we talk about a supervisor. An employee is a supervisor for other employees. So this is a relationship within the same entity set, and we can name it as a recursive relationship. And it is one-to-many, because one employee can be supervisor for many employees, and in this case, one employee can be supervised by one supervisor. A special employee can be supervised by one supervisor. So it is one-to-many relationship, as you can see. This is another entity relation diagram, or somehow semi-complete one, we can say it. I think so the last part before we go to the weak entity, it is about attributes in relationship. Attributes in relationship. Sometimes there is what we have already discussed so far, that attributes can be part of an entity set. Like here, employee attributes, departments attributes, project. But sometimes we will have an attribute that related to a relationship, not to an entity. How? Okay, Josh, you just came to my mind. Josh, are you still here? Josh, it seems we don't have any more Josh here. Or maybe he can't hear us. Okay. I see still you are here. Okay, whatever. I choose somebody else. Caleb? Who's here? Josh, you are here. Okay. Yes, I want to give an example about here. I will use your name as an example. It will be a funny example. So Josh, I have a bookshop, and I hired Josh to work at this bookshop, based on bookshops and books, for example. And I told Josh that, see, Josh, that you have book A, B, and C, 3 books. The first one costs $10, and the second one 20, and the third one 30. And then I told Josh that you can give a 10% discount for special employees. That you see that if you give this discount, then you can sell the book. And then Josh, so then there is a nice lady came, and then this lady, she asked to buy book B, which is 20. The price of the book is 20. So here in the entity set, there is price. Well, let's say selling price, we name it. And however, Josh, because she's a lady, and then he give her a 10% discount. If it is not a nice lady, maybe he will not give this 10% discount. So now the selling price for the book was, in this case, 18, not 20, as is being in the database. So it will be a sold price. So it is still an attribute for the book. However, this attribute is not related to the entity set itself. It is related to the operation when it will happen. So if the operation happen, then we will have this attribute. If there is no operation happen, still the price of the book is 20. So there are some attributes that even though they are related to a special entity set, still they are related to an operation that will happen to this entity set in order to have a value for this attribute. In this case, we name it, we include it to the relationship. Any question about this? It's very important to understand this. If you have any question, I'm happy to answer your questions. Because we have a quiz. Yeah, we will have a quiz after this. So try to ask me any question. When I said there is a quiz, I got a question. So I always said there is a quiz. Go ahead, Navapoon.
Yeah. So please go through the example about Josh.
Yeah, sure,
again.
sure. So what's your question, Navapoon?
So I just want you to go through again, like a bit more slowly for the example.
Yeah, so stay with me. Let's discuss me and you. So we will have as a book. So we have something, we name it selling a price.
Mm-hmm.
So we have book A as an instance, book B and book C. A, suppose it is 10 or 10, let's make it 10, B 20, and C 30. So now, Josh, I said you can give a 10% discount. And then when the sell as an operation happened, the price of the book was not anymore 10, it will be 9, because Josh will sell it for 10% discount. So when I will save this value in the database, where are I going to save it? Under the selling price, it is still 10. Or I should create another attribute, I name it sold price. I can put it here. However, this attribute will never happen if there is no selling. Is it correct?
Yes.
This is why I didn't put it here, this attribute, I put it here, sold price. Which means that it is still an entity for here, for this it can be, but however, this entity will never have a value without this relationship. So I put it as a part from the relationship, not the entity set. You got it? Or you still have a question? Go ahead.
Okay. Yeah, I got it.
So if you got it, maybe you can repeat it to us. Don't worry, no, you don't have to do it. If you have any more questions, tell me.
No, but Josh just want to mention that he sent some message to you on the chat, but yeah.
Josh, yeah.
Yeah. I mean,
So
on
I
the
can
group
tell.
chat, but
Don't worry. Don't worry, Josh. Yeah, I just saw your message. Yeah.
okay. That's all.
Don't
Thank
worry.
you.
Sure. So weak entity set. This is the last part before we'll go to make our exercise. So weak entity set mean that. So sometimes an entity set, I said we should always have a key for this. A key. We should always have this. However, for a reason, sometimes we are not able to create a key. Suppose we are collecting a database system or creating a database system for players, information about international players. We talk about football. And the FIFA doesn't create a special, suppose a special ID for each international player. So in the table of the player, I will have the name and the number in the team. And then I will have here the teams and the name. So if I said a player named Ronaldinho and the team number is 10, maybe I will have another Ronaldinho. I think so. We have another one. And it has a 10 as a number because most of the famous players, most of the time they will have number 10. So they will have a number 10. So both of them, they have the same name and the same number. So neither name nor number can make a key. And also both of them cannot make a key. So this entity is a weak entity because I can't create a key for this. It is a weak one. However, in this case, since it is a weak one, what I can do in this case, I can borrow a key from here. We're saying that a player that has a number 10 that play with Real Madrid, for example, now it is a unique identification. Because having the number of the player and the team name can give a unique identification for this weak entity. So in this case, I will make a double line for this entity, not only one line, because it doesn't have a key. And I make for the relationship with, we name it identification entity. It is a supportive entity, identification entity, which is an entity that will, having an attribute from this entity, I can make identification or a key for this one. So, and we have to put it as a double line for this one. So finally, the definition of a weak entity is that don't have a key attribute of their own and need a help to identify them uniquely. In this case, we name it a weak entity. A weak entity should have at least one relationship with the identification entity, but it also can have more than one relationship, but not all are will be double diamond. Just with the one that we are going to use it as a unique identification for this entity. And it should always have a total participation constraint because all of here, they need to have a team name in order to make identification. So we should always have a full participation from this side in this case. So Papa say for you, don't overuse weak entity. Whenever you can create an artificial one, go ahead and use it. This is why, for example, they in the university, they create for you an artificial key, we name it. Before you will join the university, you don't have a key. After you join the university, you have something we name student ID. Because if they will not do this, there will not be a unique identification. If we can have something here as a unique ID for the players, that the FIFA, for example, is going to provide, then it will not be any more weak. So Papa said, don't overuse weak entity. If you can avoid it, avoid it. You will have a bad design if you will have so much weak entity here. So I have a surprise for you. We will have a funny quiz. I name it Kahoot quiz game. I don't know if you are familiar with Kahoot game, Kahoot platform. So I will share with you now a link. You are going to make a quiz after I start the quiz. You will have 10 questions. These 10 questions, you will have 10 seconds to reply each one of them based on what we have already today discussed. Don't worry, there is no grade for this. It can be part of your participation in grade. But by the way, participation in grade, it's not like other assessment. If this means that if you are participant, you always show in the class. Whenever you will ask to do something, you do it during the class. In this case, you will get the full mark. It's just to give you a push to be more interactive in the class. But it is not like when you will have an assignment, I have to go one by one this. So don't worry about this grade. Just if you are always showing off in the class and always answering whenever I will ask you, mean that you interact, even though you don't know the answer, it will be perfect. However, in this exercise, I have a deal for you. So people, the first people, they will get the first one, will get plus, the first one will get plus 15 point bonus on assignment 1. The second one plus 10, and the third one plus 5. Are you ready for the quiz? So in this quiz, just you will get a bonus for the who will finish first. Are you ready? I need 5 thumbs up before we will go to the quiz. It will be a funny quiz. Yeah, that's good. I got many thumbs up. So just give me 1 second to start the quiz. I will start it and then I will share you something here in the chat. So be ready for the link that I will share in the chat. It will be a funny one. So just let me start it. I do my best to have this environment very interactive because I believe more interactive in class, it's more beneficial for you. Okay, guys. So first, I will share with you. Let me first share. So this is, you need now this code. I will write in the chat the link. You go to the link, put this code, put this code and you can start the exam. I can see you here and can see your exercise here, your questions. So go ahead. I have Nathan, Herman, Ikam now. You can see I put you on the screen. So I will start, yeah? Try to join before I will start. Yeah, I have so far 5 people here. Yeah, you should do it quickly before I start the quiz. Go to the link and put the game pin. So I have 9. I will not just type this. So I will start the quiz. I have only 9 people here. Ivan, Thomas, Herman. So I will start. Please go to the link. Go to the link and put the pin to join now before I will start. I just have 12 person here. I will start.
Professor, not seeing the option to enter this code.
We start the quiz. You still can join. Still you can join. So the first question is, which of the following plays an important role in representing? You have 10 seconds. About the real world in database. I have 6 correct questions. The data model. So the question was, which of the following plays an important role in presenting information about the real world database? Is it data definition language, DML language, the buffer, or the data model? It is a data model.
Sorry, can I get a pin again? Game pin?
I don't know if you can get it here again because I'm not sure how we can do the pin again. Let me double check. I do my best. I told you you should join, but you were late.
No, I accidentally came out.
I'm not sure if how I can get the pin. No, this is how you do it, but I don't know if I can get the pin after settings.
On the bottom right.
Here it is. Here it is. Yeah.
Oh
Here
yeah.
it
Okay.
is.
I saw it.
Yeah. 7-4. I will write here the pin in the chat. Yeah. So we will go to the next questions. Sure. Ready? Give me 2 thumbs up to continue. 2 thumbs up.
Sorry, Professor, I am unable to log it. I don't know how to enter the PIN and where to enter it.
It's okay.
I
Next time
just
you can
tried
do it.
3
It's okay.
times. Yeah.
Yeah, it's easy. I can give you it. You can go
I just
here.
put the link and there are 2 options.
Yeah.
With
You put the
login and
link. You put the link. You see this link, and then this is how it will happen. And then you put here game pin. Okay, don't worry about it. You still can do it next time. Try now, and then if you can't do it still, it will. You can encourage one of them. So next question is, so we have so far Ayman is number 1, 776, Nissan 727, Ecam 645, Callum 581, 576. Good job, Ayman. Keep it up. Ready for the next question? Select from the following multi-value attribute. Date of birth, name, phone number, all of them mentioned. Why is this? So I have some people, okay, select from the following multi-value attribute. So multi-value, it can have different value for the same instance. Date of birth? Sure not. Name? Name, my name is Ismail El Sayyad. I will not have another name. So all are, it is not a composite. First name, last name. This is a composite. This is a multi-value, which will have a different value for the same instance. There somebody has already raised his hand or her hand, and then I can see it. If there are any questions, go ahead, ask. Amen.
So are you saying that a single person can have like multiple phone numbers?
Yeah, like me, I have my home phone number and my mobile phone number. There are multiple phone numbers.
Okay. Okay, thank you.
I'm sorry, don't tell me that you didn't do it correctly. Amen, you
Oh
were
yeah,
the
I
first.
didn't.
Okay, so let's see who's now. We have Ivan. Wow, Ivan 1491. We have a Can 908, and we have Amen 776. Amen, you are the fourth. Amen, you can do it. Amen, I'm fully supporting you. So you should not do it.
Okay, thank you.
Okay, so ready for next questions. So an entity set that doesn't have sufficient attribute to form a primary key is termed as. It's too easy. An entity set that doesn't have sufficient attribute to form a primary key is termed as. Wow, I have 21 say weak entity set. Perfect. I have only one set strong. I'm quite sure he or she who said strong, it was my mistake. Don't tell me that you believe in this, even though you believe it. It's okay. Still, it is. We just discussed it today. So yes, as most of you has already mentioned, so an entity set that doesn't have sufficient to form a primary key, then it is a weak entity. This is what is a weak entity, how we define. So it doesn't have enough attribute to form a key. So let's see how is the score now. Ivan, wow, Ivan, yes, man, you are the top. And then we have a Ken. Yeah, good. Keep it up. So far you have 3 correct questions. Correct answer, sorry. And then we have Ken now the second, and we have Eamon the third now. Let's see. You should be aware that when they calculate the number, it's not only based on it is correct or not. It's based also on your speed. Do you know this?
Yeah, I played Kahoot before.
Yes.
So
like,
the quicker you are, the highest score you will get. And you have 10 seconds to answer. Okay, next. For a weak entity set to be meaningful, it must be associated with another entity set called that. That's good. That's good. So a weak entity set to be associated with another entity set we call identification. Neighbor set, sure not. Strong set, it is a variation. Owner set, no. So identification set. This is correct. This is what we have already discussed so far now. So it is a strong entity set. Yes, this is correct. However, it is a strong entity set that identifying another set. So it is an identifying set in this case. All sets that they are non-weak, they are strong. But the special entity set that will support a weak, we name it identifying set. So identifying set is a special case of a strong entity. Let's see the score. Wow, Ivan. Sorry, Amen. I should go to Ivan. It seems that he will win.
I know, I'm trying my best.
Don't worry. So we have so far. Oh, Simran now the third. So we have Ivan still the first. Oh man, you have the questions before we come here. So, so we have a Ken, and then we have a Simran. Now we have the third. So we have a new third now, Simran. Good job, Simran. Keep it up. Good job for all of you. Still, by the way, still we have 10 questions. So who's now maybe not in the top in the list, still he or she can do it. So try to focus to answer so quickly. And you should first, it will give you the question. before it starts timing. So if you know the answer, go ahead and do it so quickly, because the score is based on the correct answer and the speed also. Ready? I need 2 thumbs up to continue. Okay, so weak entity set is represented as underline, double line, double diamond, double rectangle. Weak entity set. Weak entity set. Man, I have so much. So a set, it is always rectangle. We are not talking about a relationship. We are talking about the entity set itself, not its relationship with the identification set. So it will be a rectangle, however, it is a double one. So let's see the score. The king, Ivan. So Ivan still is the first. Now we have second, and I think so it is somehow similar to what we have this question before. Okay, guys, still all of you can do it. You see here, it gives me that Harjut is the highest climber. So Harjut, you are doing good job. It means that you are going fast up. So
I feel guilty for the first question when like people couldn't get in. The win streak, I think, gives points.
Don't worry about it. No guilty for this. Still, it can be next time we will have another, maybe next time, or I don't know if we're prepared for this next time, but for sure, during this, I will do my best to have from time to time this Kahoot quiz. So, sixth question, which is not an element for an entity relation diagram? Not an element of an ER diagram, not an element. It is not an element. We are not talking about an element. So attribute is an element of an entity set, which is an element for ER diagram. A relationship, it is an element for ER diagram. Cardinality ratio, when I said 1-to-1, 1-to-many, it is an element. So data store has nothing to do with ER diagram. I have a suggestion here, nice one, I like it. So Zach said, if we pool the winnings together, we can get all +1 point. Yeah, good. Let's see. Josh, sorry that you missed 2 questions. I did my best at telling you from the beginning, try to join, but so let's see how it will be. The Ivan still the king. We have a Ken and we have a Simran. So okay, good. So
I almost hit cardinality, but I was like, I have to choose quick. I knew it was either cardinality or the data store, and I chose right.
Yeah, that's good because it's talking about not, which is cardinality is part from the ER diagram. So let's go now. 7. The attribute age is single value, derived, composite, multi-value. Yeah, go ahead, do it. Age, it is a derived. We just mentioned this. You see, people who pay attention in the class, they can do it. So when we talk about age and date of birth, we said, okay, age, it is a derived attribute from date of birth. It is single valued, but however, it is derived. So it is a special case from single value. It is not a multi-valued, and it is not a composite. Go ahead.
I know we just mentioned this specific example you talked about, but can't age sometimes not be derived? Like if we just ask for age and we don't ask for date of birth?
Yeah, you are correct. But here, since we give you a derived one, so in this case can be derived. Yeah, you are correct. It can be, if it's not always should be a derived, but when it is a derived, it is one of maybe if you maybe the question I saw said that attribute age maybe is maybe I have to use other word to be more specific. But the aim from the question, since you have a derived and derived can be applied here, so it for sure it's not composite. For sure it is not a multi-valued. Maybe people will be somehow confused between single valued and derived. So if it is a derived, you are more specific in this case. I agree on this case, it should be derived in this case. Somebody has already raised his or her hand. Josh, maybe? No question? Okay, let's continue. Let's see first how we have. So Ivan now, but Ken, you are very close to Ivan. Ivan, take care, yeah? You are very close one. Ken is very close to you. Maybe he will hit it. Simran Paramveer, now Paramveer is a force. That's good. Okay. I need 2 thumbs up to continue. Or I will stay here. I have Amen, Josh. Okay. So, 8. Which is set of entity of the same type that share the same preparative attributes? Okay, so the question say which set of entities, entity set, of the same type that share the same preparative attribute? Which is set of entities. It is a set of entities, so it is an entity set of the same type, like the car, Toyota, Nissan, they are all from the type of the car, which is from this entity. It is not a relation set because we don't use this word. It is not an attribute set. It is not an entity model. It is an entity set. So let's see how we have here. Wow, Ken and Ivan is very close. The next question will tell us who will be the first. And by the way, also, Simran, you are extremely very close to them. So the next question, you said, who's the first? So Ivan and Ken and Simran, they are very close. Oh, now we have Kalon, you are the highest climber for this. Next. Ready? I need 5 thumbs up to go to the next because this is maybe the last one. Yeah. We can go now. This is a 9. Still we have 2. The number of entity to which another entity can be related through a relation set is called. Yeah, it's an easy one, cardinality, because it's talking about number of participants on both sides. It is not a schema for sure, because the number of entity to which another entity can be related through a relationship set is called. So let's talk about constraint about in participation, and talk about the maximum number, about the number of participation. So it is about cardinality that we have already discussed today. So Ivan, wow, and Ken, we are extremely close. Simran and Paramveer, Simran, you are extremely close to them. And then we have here Navapun is the highest climber. That's good, Navapun, keep it up. Man, this is now the 10th one. So the first will get plus 15, the second plus 10, and the third is plus 10, is plus 5. So, ready? The last question for this. Ready? Okay, that's good. That's good. Yeah. The last one, 10. Which of the following is not true? Not true. B. I have 17, so a special symbol are added to show high-level business rule. So similar, because we talk about business rule here, special symbols. We use rectangle for entity relation diagram. We use diamond. So we're talking about business rules here. Similar kind of information are listed together on entity. Yes, this is the entity set. lines are drawn to show relationship among the data. Yes, there is a line, and then we will go a relationship, and there is a line to the attribute. So we use lines here. The diagrams are drawn in a sequential order from top to bottom. This has nothing to do with a sequential. I can start with this entity set with the employee, or I can start with a menu with a project. So there is no hierarchy here. So there is nothing about sequential order or top to down. So yes, now we should know who's the top 3. I need 10 thumbs up to show you the result. 10 thumbs up or no result. I have 2, 3, more. Yeah. Okay. So you are ready? Ready? Simran the third. Ken the second. Who's the first? Ivan. And we have the good runners, Kenwa the fourth, and the fifth who? Congratulations, guys. Yeah. So I just take a note here. So we have Ivan, and yeah, it will show me Ken, Ivan, Simran. So Ken, you will get +10 for assignment 1, and Simran, you will get +5. And Ivan, you will get +15 in assignment 1. Yeah. Yeah, I want to thank you all for this. It was funny, nice to do it, and it will give us some motivation, and we share some discussion during the quiz. And still more, still more coming, so still the others can do it. So this is, maybe I will share with you later some report about this. So let me share again the presentation. Do we have it for today? I hope that you have already enjoyed it. And I think so it was a good opportunity to practice what we have already discussed so far today. Okay, guys, still we have small amount because of the quiz, maybe it take. So the last part for today is just we need to make an exercise with each other. The exercise says that you have a comp bank that has branches located in different cities. And each one is identified by a unique name. Each branch has yearly budget and rating, which is a number from 1 to 10 for each branch. The customer of any branch is identified by their customer's name and phone number. The bank also keeps track of each customer current address. The branch offers accounts and loans to its customer. Each account has a loan and a unique number. Each account is assigned to one or more customers, and its balance can never be negative. A loan is always assigned to a single. We have people here. So, and a loan is always assigned to a single customer, has a fixed interest rate, and its balance cannot be negative. What I will do now, I will break you down maybe to 5 to 6, 7 groups. I will double check, and I will put each one of you in a room. Just 15 minutes. So we will you will discuss 15 minutes, sketch the ER diagram, and I will join each group in their group to see how we can draw the ER diagram for this. So you have the lecture, so you can return back to other places. You have the lecture without this exercise. So I will, maybe you need, oh, sorry. Maybe you need the data here for this requirement. I will share it again, sorry. I need to share it again. So I will write in the chat here. What you should use whatever it is. You can use any software. So you can use Calum. There are some softwares. I don't want you to buy one of them. So just because it is just a rectangle diamond lines, you can use PowerPoint, you can use Word, you can use any sketch or Sketch. And if you want later to send me your assignment, you can draw it by hand and send it to me. So use any software you feel it is comfortable to you. So because it's very small, so just we have an ER diagram, a table, and we have ovals, and we have a diamond. So it's up to you. So let me break you down to different rooms. So create rooms automatically. I will create rooms. Wait. Okay. So yeah, so I create the room, I start opening them now. So you will go to rooms, you will discuss internally, if you have 15 minutes to discuss how the ER diagram, and one of you can start sketching with the others about this. So Harjut, you just joined, you are not in a room? Assign participant. I will assign you to any room. Let's put you in room 5. Malik, why you are on hold?
Okay.
Hi.
Hi, Prof. We have a question.
Yeah, I will answer. Let's first be sure that all people return back to you.
Okay.
Is my screen still showing?
Sorry?
I was asking my group if my screen still showing for you guys in the group?
No, I closed all the groups, so you return all to the main lobby now. You're not going to.
Oh, we are in the main room now. I thought we were
Yeah.
in the group. Okay, sorry.
Because I told you you have 15 minutes to do it, and then we return back here to the main lobby.
Right.
Yeah. Yeah. So before I will discuss my my solution or a proposal for my solution, because in our diagram, not always we have a black and white solution, which means that correct, incorrect. Sometimes we will have different versions for the solutions, and all can be correct in this case. And sometimes we will have a version that is correct but is incomplete. So do any group want to share with us their solution before I will show a sample solution? Any group want to share their solution? Josh, you want? You and your group? Okay, go ahead, do it. Share your screen and so you will have, can you use a mic, Josh? Well, I can see here you have, let me be more quicker area. Brighter area, okay. Don't worry, even though if it is not so much quiet, it's okay. So you have a customer here, you have an offer, and then so for you it is a customer, it is, yes, it is an entity. And then you will have an account as an entity. And you have a branch as an entity. And you have a loan as an entity. Okay. First,
I'm
I
in
agree
a
about.
quieter area now.
No, it's perfect. We can hear you very clearly.
Yeah, no, it's just I had to go to school because our engineering department was having a meeting
I see.
last minute. So yeah. Yeah, so I have customer as an entity, which is defined by their name, their phone number, and address. The name and phone number are in conjunction, are key, simply because the name could be the same or the phone number could be the same, but it's unlikely that both are the same at the same time because you'd be living under the same roof. So we decided that that would be the key, but this could be considered kind of a weak entity. Then we have the branch over here. It has a city, a name, a budget, and a rating. The name is unique, so that's our key. Then these branches offer loans and accounts, which are both entities, and each of these have unique numbers. So I didn't have a chance to put the line there. Okay. So they have their key attribute there. Now, each branch, it's each branch, so there's just one. There's any number of loans and any number of accounts, and they all participate in this. Next, these accounts are assigned to customers. The accounts are assigned to any number of customers, and not all customers are forced to participate, from my understanding, just because it doesn't specify that. So one account is assigned to multiple customers, and then a loan can be assigned to a single customer.
Yeah, but also a customer can have different accounts also.
Yeah, so this should be.
Yeah, you have a checking. You can have a checking account. You can have a saving account. So all accounts that you are owning.
I was just going with what we were given, and with our given input here, we were only told that the accounts can have multiple
Yeah,
customers.
in this case, I agree with you. And again, this is what I said. Sometimes it's the way you can understand the requirement. And if it is not somehow gray, it is not mentioned clearly. So it depends on the designer in this case.
Yeah, my main focus was designing it as if customer had asked me, hey, design this, and this is what I need exactly. So that's what I follow.
Perfect.
But yeah, no, I can put them in here and that fixes it up.
I can say that my solution.
Some of these lines might not be quite right, but yeah.
Yeah, don't worry, because of the time you will have it. But it was an amazing work. I really like that you can do it almost correct. This is a very nice job, knowing that we have today already. It's the first time we discuss ER diagram. So good job, you and your team. It was a perfect job within 15 minutes. Perfect. Thank you so much, Josh. Yeah, let me share mine in this case. So it is somehow similar to what Josh had already said. So the first point when you draw an ER diagram is to agree first about the entity. So we start with the entity set, then we go to the relationship. So if I will draw this, I will not draw this first. So forget about this, forget about this. The first point you have to do it to see how many entity set you will have. You have account, branch, customer, loan. As Josh said, here I said a customer of any branch is identified by the customer's name and phone number. So I have a concept that have some parameters, so I should create an entity set for this. And here each branch has a yearly budget and blah, blah, blah. So I have a branch that have, so I should create an entity set. And then branch offer accounts and loans. So customer, each account has and loan has a unique number. So we talk about now about loan and account. And since I name it here ID, so you can, it's number, it is a unique, so I can use it as a primary key. And here it was mentioned that, and each one has identified by unique name, so it can be used as a unique here. So I finish first the entity set, their attributes, if there is a special attribute, there's key, their keys, and then I start thinking about relationship. So first we should finish the entity sets that we have. Do we include all entity set based on the concept? How you can know, as I said, if you have any concept that has some description and attributes, in this case, I need to create an entity set for this. And then I think about relationships based on this requirement. It said that each account is assigned to one or more customer. So an account can have multiple customers and a customers can have a multiple account. A loan is always assigned to a single customer. So a loan assigned to a single customer. So it would be one from here. So a loan. And for sure, a customer can take more than one loan. And a loan can be offered by a special branch. So it is one. And a branch can give more. After I finish the Cardinalary Ratio, and then I have to think more about the participation. So, sorry. First, do the entity set, do the relationship, and then think about this cardinality constraints ratio. And then the last step is talk about participation. So a customer, not all customers will take a loan. But whenever there is a loan, there should be a customer. So this is full participation, and here single participation or partial participation. The same. Whenever there is a loan, there should be a branch, but not maybe it is a new branch. We don't have so much loan so far. So when you start a branch, maybe you doesn't have so far loan. So the same like customer account. So whenever you have an account, you should have a customer. So all accounts have customer. There is no account without customer, full participation. But maybe you have a customer that now it's not anymore have an account. It close all its account, his account or her accounts. So in this case, it is partial participation. This is our ER diagram based on this requirement. And then The next step will be the next lecture. We will go from entity relation, like something we name it enhanced entity relation diagram to add more detail. And then we will go to the logical design to have a relational schema. This will be two main concepts, our next lecture. And I will upload the assignment 1 today for you. You will have a 1 week because I told you that I would push the assignment because after the holiday that we have it the last week. So if you have any question before we will leave today, I'm extremely happy to answer all your questions. Go ahead and ask me now. Amen, go ahead.
Do we have to upload the diagrams on Blackboard, or was it just for the practice?
You're talking about what?
For this diagram.
No, you have just to do it for practice.
Okay.
You should upload the diagrams for the assignment after I publish the assignment as a Blackboard.
Okay.
So I will publish the assignment with Blackboard. If the ER diagram, you can do it handwritten or use any software, and then you will upload the file to the Blackboard for the assignment. And we have today 3 people got bonus, and I will collect the attendance before today based on what you write in chat present. And we have 3 people got bonus, Ken and Aiden and Ivan and Simran. The first one 15 and plus 10 and plus 5. I hope that you enjoyed today. I will do my best to have always interactive lectures. If you have any suggestion or any feedback you want to share by email, I will be happy and extremely happy to get this feedback. If there are no any more questions, I need 5 thumbs up to leave, or we will stay. You want to leave? Thank you so much for today. See you next week and take care. And I hope that you will have a nice evening. Take care all. Okay.